Hello everyone, and welcome to our promising talk. My name is Maya, and I work on the V8 team in Google.
Yeah, my name is Benedikt. I also work on the V8 team at Google.
So V8 is a JavaScript engine that was originally created for the Chrome browser, but nowadays also powers Electron and Node.js.
Yeah, speaking of Node.js, some of you might have seen this legendary talk from Gary Bernard, which is called The Birth and Death of JavaScript, where he speaks about JavaScript. And he also has some things to say about Node.js. It's actually a really funny talk, although this one wasn't really funny, depending on how you see it.
You mean the talk in which he rants about the callback hell?
Yeah, exactly. And actually, that seems to be a direct consequence of not having promises in Node.js for a long time. And coincidentally, that's also one of the main regrets that Ryan Dahl, the creator of Node.js, shared earlier this year.
Fortunately, that's already been addressed.
You mean I don't need to write code like this anymore?
No, Benedikt, for heaven's sake, please don't do that. Every time you do it, you're gonna kill a puppy.
Oh, I'm not gonna kill this one, no. It's so cute.
Yeah, that's what I thought. So you know there are promises since ECMAScript 2015?
Yeah, I think I've heard of it. And I have to admit, this code looks a lot more readable than what we saw on the previous slide, but it's still not really ideal.
Oh, then what about async functions? How do you like this version?
Yeah, I think this is readable. But speaking of readable, so what about this readable streams code? I think this is not really readable to me. Especially the handling of data and the end of file signaling. I think this is kind of hard to read.
Yeah, that's a very common problem indeed, but fortunately JavaScript has a solution for it as well. So we already have async iteration, which is going to make writing code like this a lot easier on the eyes.
Wow, so async await is really here to save the day.
Yes, and fortunately that's already here nowadays. So you can use async functions since Node 8, and async generators are fully supported since Node 10.
So this is the Twitter slide if you want to take pictures.
So Benedikt, I also heard we held on to some performance promises that we made our own promises, didn't we?
We did, yes, indeed. So here's what we managed to accomplish between Node 7 and Node 10.
So we can benefit from that already?
Yes, as you can see, both Node 10 and Node 8 are performing quite well on, in this case, the docspeed benchmark. On the parallel test, which is also a promise benchmark that specifically stresses promise.all, we managed to squeeze out even more performance.
Whoa, that looks like a factor of 8 improvements in some of the cases. But still, these are micro benchmarks, and if I remember correctly, you wrote them?
Yeah. Actually, I didn't write them, but I adopted them. But you're right, you have a point. So those are micro benchmarks, so you can always create a benchmark that shows how awesome you are. So let's look at some real-world improvements and see if there's a correlating improvement. And as you can see, there is one. So these are popular HTTP middleware frameworks, and specifically the ones that make heavy use of promises and async await. Also notice that on this slide, higher is better, whereas on the previous, lower was better. And we spend a lot of time making promises and async functions cheaper.
That sounds exciting. Can you elaborate on it a bit?
I can, yes. So first of all, notice that if you use Microsoft products, then the emojis are a bit sad. But imagine those are different anyways.
But they're still there.
They're still there, at least, yeah, okay. So first of all, shameless plug, we shipped Turbofan in Node 8, which is the new optimizing compiler, and that gave a huge boost across the board. Then we also introduced a new garbage collector, which is called Orinoco, and you will hear more about it tomorrow. And last but not least, Node 8 had some really handy bug in await where it was sometimes skipping microticks, which gave some performance improvements.
Wait, what? I only thought we promised to write optimizations, not bugs. What bug are you talking about?
Yeah, technically you're right, but sometimes we slip in some bugs just to make it faster. Anyways, okay, so let's look at this example. So here we create a resolved promise P, and then we await on it, and then we chain two handlers on it. So just looking at this code, what do you think is the output of it?
Since P is already resolved, I'm assuming that first we'll see the after await being printed, and then the two ticks.
Yeah, that's kind of what you get in Node 8.
But
this is not correct. So the correct behavior is the one in Node 10, where you first print the two ticks and then the after await.
My gut feeling is that this correct behavior is more surprising to people, and this clearly deserves an explanation.
I agree. So, but before we dive into the magical world of promises and async functions, let's briefly look at some of the foundations.
So don't worry, the following content is quite advanced, but we'll try to go through it step by step, and we'll highlight the key takeaways. So.
Okay, so first, on a high level, there are two things. There are tasks and microtasks. So tasks handle events like I/O and timers, and they execute one at a time. Microtasks are used to implement the deferred execution for async await and for promises, and they execute at the end of each task. Specifically, the microtask queue is always emptied before execution returns to the main event loop.
Right, there is also this awesome blog post by Jake Archibald in which he talks about scheduling the microtasks in the browser, and Node.js's model is pretty similar to that. But enough being said on microtasks, let's dive into async functions and await.
Yes, so if we check MDN, then an async function is a function which surprisingly executes asynchronously and uses an implicit promise to return its result. And async functions are meant to make asynchronous code look more like synchronous code to hide some of the complexity of the asynchronous processing from the developer. So this is the simplest possible async function that you can write. If you call it, you get a promise out. And like with any other promise, you can get to its value by just chaining something onto it. Especially that means async await, or specifically async functions, are always lazy, which means you will only get to the value on the next time the microtasks are run. And this is more or less semantically equivalent to just using promise resolve with this value. The real power of async functions, though, comes from await expressions. So an await expression causes the function execution to pause until a promise is resolved and resume after fulfillment. The value of the await is that of the fulfilled promise.
So is that what MDN means by saying that await is there to make a synchronous code look like synchronous?
Kind of, yes. So what this really means is that if you have code like this, then the execution of the async function is suspended on this await, and it's only resumed once the fetch promise fulfills. Which means if you call it, you again get this implicit promise out, and then you can wait on it, and this promise will eventually resolve to the status code, which is ideally 200, if everything goes well, once the fetch completes. And this is more or less equivalent to chaining a handler onto the fetch promise. And the code in the handler is essentially the same code that follows the await in the async function. So now, since we learned from Gary Bernard earlier, but maybe you also know this as well, JavaScript is awesome. So you can not only await promises, but you can actually await any value, which I'm not really sure is very useful, but anyways. So if the thing that you pass to await is not a promise, then it's implicitly converted to a promise. So that means if you feel like awaiting 42, then you can do that, and it will work.
Yeah, very useful.
Yeah, I can totally see use cases for this. Not. But anyways, you can do it. More interestingly, you can await on any thenable, which is any object that has a then method on it. This object doesn't even need to be a real promise. So you can implement funny things like I did here, asynchronous sleep that measures the actual time spent sleeping.
That actually sounds useful. I think I might use it.
Okay, so I found user for my awesome code.
Okay, so let's see what V8 does for await. Here's a simple async function foo, which takes a single parameter v. When called, it will wrap this value into a promise and suspend its execution until the promise is resolved. So once that happens, once the promise is resolved, the execution of the function continues, and W gets assigned the value of the resolved promise, and then we return the value W from the async function. First of all, V8 marks this function as resumable, which means that it can be suspended and resumed at later points, which are the wait points. Then it creates the so-called implicit promise, which is a promise that is returned when you invoke the async function, and is later resolved with the value produced by this async function. The second step is where the value passed to the async function to await is wrapped into a promise. And then we attach the handlers to resume the async functions once the promise is resolved. Then we suspend the execution of foo and return the implicit promise. Eventually, we resolve this promise W. We resolve the implicit promise with the value returned from the await.
Okay, so just zooming on the await in this case, that means await, in a nutshell, we first have to wrap it into a promise, then we attach handlers for resuming the async function, and eventually we suspend execution of the async function and return the implicit promise to the caller.
Exactly. Let's go through this operation step by step. So first of all, we assume that we are awaiting on a promise that is already resolved with the value 42. Then we create a new promise and resolve it with the thing that you are awaiting, which does deferred chaining of these promises on the next turn, expressed via what the specification calls promise resolve deniable job. And don't worry about this name for now. Then we create another so-called throwaway promise, which is called like this because it's only internal to the virtual machine. Nothing is ever chained on it. Then this throwaway promise is chained on the promise via this perform promise then operation, which is essentially what promise.prototype then does. So then we suspend the execution of the async function and return control to the caller. Then some other JavaScript gets executed. Eventually, the call stack becomes empty. And then we start processing the microtasks that we scheduled before. We run the previously scheduled promise resolve deniable job, which schedules another promise reaction job to chain the promise onto the value passed to await, which was V, if you recall. Then we return to the microtask processing, since as Benedikt just said, we first need to run all of the microtasks until we continue with the main event loop. And we run the promise reaction job that we just scheduled. It fulfills the promise with the value that we were waiting on, 42 in our case, and schedules another promise reaction job on the throwaway promise. It returns to the microtask loop again, and we see this final microtask to be processed. Then we run it, and it propagates the resolution to the throwaway promise itself. And since it had the handlers to resume the async function, now we suspend the execution because we have reached running the handler, and we return 42 from the await.
Holy camoli, that was a lot of information. Also, not really surprising that await is not really fast. So that really reminds me of this animal, which can spend a lot of its lifetime not moving at all. Seems like await is like this animal a bit.
Yeah, a little bit. I mean, it moves, but nobody really notices it, since it only happens in the virtual machine.
I see. Okay, so summarizing what we've learned here, for each await, the JavaScript engine has to create 2 additional promises, even if the right-hand side of the await is already a promise. And we need at least 3 turns to the microtask queue to process this. And to be honest, I think this is a bit too much overhead for my taste.
Hopefully so. So let's actually see where this overhead comes from. If we just take a look at these first 2 lines, the first of them is responsible for creating the wrapper promise, and the second line immediately resolves it with the value passed to await.
Right, so if I see this correctly, then just these 2 lines alone are responsible for 1 additional promise, plus 2 out of the 3 microticks?
Exactly, and that's quite expensive if the value that you are await on is already a promise, which is the most common case, since await was mostly created for awaiting on promises.
Yeah, right, but in the unlikely case that I feel like awaiting 42, we still need to wrap it into a promise then.
Exactly, and this is where we find this handy operation in the ECMAScript spec. It's called promise resolve, and what it does, if you pass any promise to it, it returns it unchanged. If you pass any value that is not a promise, it wraps it into a promise. So it basically does what we did before, except in the case that you've passed a promise, then it saves the extra work. So that's currently implemented behind the Harmony await optimization flag in V8.
And we also want to merge this into the JavaScript specification?
Yes, once we are sure that it's web compatible.
Cool. Can you explain how this works?
Sure, let's go through this new await step by step again. So assume, again, we are waiting on a promise that is fulfilled with the value 42. Thanks to the magic of promise resolve, on this first step, we do nothing because we have already passed a promise. Then we create the throwaway promise as before, and schedule the promise reaction job to resume the async function on the next tick of the microtask queue. We suspend the execution of the async function and process some more JavaScript, and eventually the call stack becomes empty. So now we start processing the promise reaction job that is on the microtask queue, and we execute it, and it propagates the resolution from promise to the throwaway promise. And it resumes the execution of the async function. It yields 42 from the await. So to summarize what we have accomplished here, we managed to get rid of one of the extra promises that we created for the most common case that the value awaited on is already a promise. And also we reduced the 3 microticks that we had on the microtask queue before to just 1 for this case.
Nice. So that's really close to what we had in Node 8, where we would also skip some microticks in await.
Yes, except that it's not considered a bug anymore.
Yeah, that's awesome. That's best performance. Okay, so this is pretty huge, but you know what still rubs me the wrong way? This need to create the throwaway promise. It doesn't seem to be very useful.
Yeah, your gut feeling is right. So the throwaway promise is there actually only to satisfy the internal API constraints of this perform promise then operation. And thanks to a recent change in editorial change in the spec, the JavaScript engines no longer need to create this throwaway promise for await most of the time.
Most of the time?
Well, there is no good rule without an exception. And the exception actually comes from Node.js, because it uses the throwaway promise for its async hooks, which are an amazing feature, and it needs to schedule the before and after hook around await on this throwaway promise.
Okay, so to summarize these optimizations, here's what an async function turns into now. So this is tip of tree V8. Specifically, if you compare this to what we had in Node 10, that's quite a significant improvement. And you can see this. So it's almost like async await is wiping the floor with handwritten promise code now.
Yes, and maybe that's not even the end of the story.
Ah, gotcha. Okay, so that's what awaits developers in Node 12 with respect to asynchronous performance.
Yes, we significantly reduced the overhead of await, and that's not just for V8, but across all of the JavaScript browsers.
That's really awesome. So I guess we are done for today?
Well, almost there. So, you know, when I was a Node.js developer, I was concerned with the performance of my application, of course. But what was my main concern with asynchronous code was its debuggability, especially when things didn't go the way that I expected.
Yeah, I think that's a quite common pattern that you only need debugging when things start not working.
Yeah, I guess.
Unless it's so fast that you don't even notice the bug. Anyways, there might be something that helps you, which is this awesome feature that we have in Chrome DevTools, which is called async stack traces. Have you seen that?
Yes, it is very useful indeed. I used it a lot while developing my application, but then when I deploy my server to production, and there is some error in my asynchronous code, I only see that as the error.stack property in the log files. And it doesn't tell me anything about the async parts of my code.
Yeah, guess what? I've been recently working on something that might help you here. It's called zero-cost async stack traces, and it's supposed to enrich the error.stack property with async function calls.
Whoa, zero cost sounds exciting, especially for production. Can you say a bit more about it?
Yes, it's like free lunch, essentially, except that it exists.
Okay.
Okay, so consider this example. We have an async function foo that calls bar asynchronously, which just means it calls bar and awaits the result. And inside of bar, we throw an error after awaiting on some promise.
Speaking from experience, the error.stack property will only contain the bar function at this point.
Yeah, not really only that, but the rest doesn't help you any further, I guess.
Yeah, I like seeing these Node.js internals that I didn't even know that exist.
So anyone else have bitten by this in the past? Oh, wow, okay. So you're using DevTools a lot, I guess. Or you're not using asynchronous functions a lot. Okay, yeah. The interesting bit, though, is that the JavaScript engine knows where it has to resume when it's done executing bar, because that's exactly right after the await inside of function foo. And coincidentally, that's also the place where foo was suspended.
You mean that for await, the suspend and resume points are the same, actually?
Yes, exactly. And we can use this information to reconstruct parts of the asynchronous stack trace, namely the await sides. And that's exactly what this new --async stack traces flag does. So the topmost function comes first, which is the foo in this, which is bar in this case, with the rest of the synchronous stack trace, which is some node internals that you probably didn't even know existed, but now you know. And afterwards comes the async part of the stack trace, which is the function bar, which is the function foo that was asynchronously called from bar.
Awesome. But what happened to the call side of the foo function? We used to see it in Chrome DevTools, and we don't see it now?
Yes, as mentioned before, this approach utilizes the fact that for await, the resume and the suspend location are the same, whereas for regular promise then or promise catch calls, like in this case it's promise catch, this is not the case. So the approach is currently limited to await.
Well, I think my brain is already melting, and I think we need another cuteness break.
Yeah, just look into these eyes for a while, and then you will totally relax and see how this thing is waving. Hello, NodeConf.
Okay, shall we resume?
Yes, so good news is we're almost done. So let's recap on what we've learned today.
So we get faster async functions due to two significant performance improvements. That's the removal of the 2 extra microticks and also the removal of the throwaway promise.
Yes. On top of that, we improved the developer experience via zero-cost async stack traces, which work with await in async functions, and as of last week, also with promise.all.
Cool. We also got some nice performance advice out of this, right?
Indeed. So first, always favor async await over handwritten promise code for increased readability and debuggability, and try to stick to the native promise implementation offered by the JavaScript engine, which is hopefully V8, to benefit from the shortcuts, avoiding the 2 microticks from the await like we presented here. And that's it for us today.
Thanks for listening. Be sure to follow us on Twitter if you're interested in more things about JavaScript, async programming, and performance.